Hello, science fans! Today we are going to talk about something amazing. It is something you cannot always see, but it is all around you. I am talking about gas. Think about the air you breathe right now. That is a mix of different gases like oxygen and nitrogen. We need gas to live. Every single breath you take is a little bit of science happening. Gases are not just for breathing though. They fill up the balloons at a birthday party, making them float and bob around. They make the bubbles in your favorite soda pop and fizz when you open the can. Understanding how gases work is not just for scientists in a lab, it is for everyone. Gases are a special state of matter. Unlike solids, which have a fixed shape, or liquids, which take the shape of their container, gases go everywhere. The tiny particles that make up a gas are full of energy. They zip and zoom around, bouncing off each other and the walls of whatever is holding them. Imagine a room full of super bouncy balls that never stop moving. That is what gas particles are like. This constant motion is what gives gas its unique properties. It is why you can smell a pizza from across the room. The gassy smell particles travel through the air to your nose. It is a world of invisible, energetic action. This energy and movement mean we can do some really cool things with gases. We can squeeze them into small spaces, like when we put air into a bicycle tire. We can heat them up to make things expand, like a hot air balloon rising into the sky. We can also cool them down to make them shrink. The way gases behave when we change things like pressure, volume, or temperature is described by special rules. We call these rules the gas laws. They are like a recipe book for how gases will act, and they help us understand the world in a whole new way. Let's get ready to explore these amazing laws together. Knowing about these laws is incredibly useful in our daily lives. It helps us understand why a bag of chips looks so puffy if you take it up a mountain. It explains why you should check your car's tire pressure when the weather gets cold. It is science that is practical and fun. By the end of our journey today, you will see how these simple rules are at play in so many things you see and do every day. So put on your thinking caps because science is about to get very exciting. Let's dive into the fantastic world of gas laws. Consider this. Our first stop is a very important rule called Boyle's Law. This law is all about the relationship between pressure and volume. Imagine you have a gas trapped inside a container, like the air inside a bicycle pump. Boyle's Law says that if you squeeze the gas into a smaller space, its pressure goes up. Think about pushing the handle of the pump down. You are decreasing the volume, or the amount of space the air has. As you do this, the air particles inside get squished closer together. They start bumping into the walls of the pump more often and with more force. This increased bumping is what we call pressure. So, the rule is simple. When the volume goes down, the pressure goes up. It also works the other way around. If you give the gas more room to move, the pressure goes down. Let's go back to our bicycle pump. When you pull the handle back up, you're increasing the volume inside. Now the air particles have a lot more space to zip around in. They will not hit the walls as often, so the pressure inside the pump decreases. It is like a dance between space and force. Less space means more force. More space means less force. This is true as long as we keep the temperature of the gas the same. A perfect example of Boyle's Law that you might see every day is a simple syringe, the kind without a needle that you might use for medicine. If you put your finger over the end to block the hole and then push the plunger in, you can feel the resistance. You are squeezing the air inside into a smaller and smaller volume. The pressure of the trapped air pushes back against your thumb. You can feel the pressure increasing. If you let go of the plunger, it might even spring back on its own because the high-pressure air inside expands, pushing the plunger out to increase its volume again. This law is happening all the time. When you breathe, your diaphragm muscle moves down, increasing the volume of your chest cavity. This lowers the pressure in your lungs, and air from the outside rushes in. Then your diaphragm moves up, squeezing your chest cavity. This increases the pressure, pushing the air back out. Even the bubbles in a scuba diver's tank demonstrate this. As a diver goes deeper, the water pressure increases, squeezing the air bubbles to make them smaller. Boyle's Law is a fundamental principle that explains so much about the push and pull of the invisible world of gases. Incredible! Next up, let's explore another fascinating rule called Charles's Law. This law connects two different things, temperature and volume. It tells us what happens to a gas when we heat it up or cool it down. Charles's Law states that if you increase the temperature of a gas, its volume will also increase. Why does this happen? When you heat a gas, you give its tiny particles more energy. With more energy, they start moving much faster and with more force. They zip around and crash into the walls of their container, pushing outwards. If the container can stretch like a balloon, it will get bigger. Think about a balloon you might have at a birthday party. Imagine you leave it in a nice, warm, sunny room. The heat from the sun will warm up the air inside the balloon. This gives the air particles more energy, making them move faster and push harder on the inside of the balloon. As a result, the balloon will expand and get slightly bigger. Now, what happens if you take that same balloon and put it outside on a very cold day? The cold air will cool down the gas inside. The gas particles will lose energy, slow down, and not push as hard on the balloon's walls. The balloon will shrink and look a little deflated. A fantastic big-scale example of Charles's law is a hot air balloon. How do those giant balloons float up into the sky? The pilot uses a huge burner to shoot flames and heat the air inside the balloon. This makes the air particles inside get super energetic and spread far apart. The air inside the balloon expands and takes up a lot more volume. This makes the air inside the balloon less dense or lighter than the cooler air outside the balloon. Because it is lighter, it starts to rise, carrying the basket and its passengers up, and away. To come down, the pilot lets the air cool off. It shrinks, becomes denser, and the balloon descends. This principle is at work in many places. Have you ever noticed a loaf of bread rising in the oven? That is partly because of Charles's law. The yeast in the dough produces little bubbles of carbon dioxide gas. As the oven heats up, these gas bubbles get hot and expand, which makes the whole loaf of bread puff up and become light and fluffy. So the next time you see something get bigger when it gets hot, you can think of Charles's law. It is the simple, powerful idea that heat makes gas expand and cold makes it shrink as long as the pressure stays the same. Science is delicious. Our final law for today is sometimes called the pressure law, or Gay-Lussac's law. This one connects temperature and pressure. It is a bit like Charles's law, but instead of the volume changing, we imagine the gas is trapped in a container that cannot change its size, like a metal can or a car tire. The pressure law says that if you heat a gas in a rigid container, its pressure will increase. Once again, heating the gas gives its particles more energy. They zoom around faster and faster, but now they have nowhere to go. They are stuck in the same amount of space. Because the particles are moving faster in the same fixed volume, they will smash into the walls of the container much more often and with much more force. This is an increase in pressure. A great example is a car tire. On a hot summer day, the sun heats the road and the road heats your tires. The air trapped inside the tire gets hotter. The air particles get more energy and start banging against the inside of the tire with greater force. This is why your tire pressure is higher after a long drive on a hot day. It is also why you should never overfill your tires, especially in the summer, as the pressure could get dangerously high. This law also explains why you should never ever throw an aerosol can, like a can of spray paint or deodorant, into a fire. An aerosol can is a strong metal container with gas trapped inside under high pressure. If you put it in a fire, the gas inside gets extremely hot. According to the pressure law, this will cause the pressure inside the can to increase dramatically. The can is not designed to hold that much pressure. Eventually, the force will be too great, and the can will explode, which is incredibly dangerous. This is a very important safety lesson that comes directly from understanding this gas law. But this law is also used to help us. A pressure cooker is a perfect example. A pressure cooker is a sealed pot that traps steam, which is a gas, inside. As you heat the pot, the water turns to steam, and the temperature and pressure inside the pot build up. Under this high pressure, water boils at a much higher temperature than normal. This higher temperature cooks food much faster, saving time and energy. So from keeping our tires safe to cooking our dinner quickly, the pressure law is a vital scientific principle. Understanding these laws helps us stay safe and have fun with the amazing science all around us. Now you know.